A key feature of our approach, arguably the key feature, is that we design our games to break the symbol barrier. Research has shown that when people have to use everyday mathematics on a regular basis, they rapidly become proficient. The reason so many people find math hard to learn is because of a linguistic obstacle: math's symbolic language. That's the symbol barrier. Brainquake breaks the symbol barrier by developing alternative representations of mathematics that avoid those abstract symbols. Here are the 4 different kinds of gear puzzles. Beneath each puzzle is the equation for which that puzzle is an alternative, non-symbolic interface. The resulting sequence of equations you're solving, when you repeatedly rotate the cogs to collect items, can look pretty complicated. And this is a mid-level puzzle with just 2 cogs. What I want to stress is that when you solve the puzzle by rotating the cogs, you really are solving that system of equations. In terms of arithmetic, you're doing the very same sequence of steps. The reason it looks and feels a whole lot easier when you solve the puzzle is that the puzzle provides a much more learner-friendly interface than the symbolic equations. That's breaking the symbol barrier.
How do I? Oops.
4?
I can 4 back, yeah.
Ten back?
Uh-huh.
Which way? This way?
Yeah. Nice job. One more?
It's hard.
Let me stress that the goal of the Gears puzzle is not to teach you how to solve systems of linear equations. Indeed, none of our puzzles is designed to develop specific math skills. Rather, we aim for general mathematical thinking ability and all-round problem-solving skills. Since both of those are transferable across all of mathematics, it doesn't really matter which mathematical topics our games are built on. In the case of the Gears puzzle, it brings in a wide range of mathematical topics, some of them very basic, others generally discussed only in university postgraduate research seminars. I should observe that not all parts of mathematics lend themselves to non-symbolic representations in interactive apps, particularly apps that are engaging and can be presented in a game format, at least not in a good game format. So we select topics for which the puzzle game format works particularly well. We're not trying to replace good teachers or textbooks. Rather, we leverage the power of digital games to achieve maximum impact by providing learning materials that supplement existing resources. Because games are real-world artifacts that embody mathematics, they typically do not capture one specific math skill. What connects all the math topics you see on this list is the Gears mechanism. By solving a sequence of Gears puzzles, a player develops a degree of understanding and mastery of all those different mathematical topics.